According to Henry's law, the diffusion of a gas depends upon its partial pressure and the solubility of gas in water. So, the greater the partial pressure of a gas, the faster the speed of diffusion. Now, when we think about inspired air, nitrogen has the greatest partial pressure. The amount of nitrogen in atmospheric air is 78%. Oxygen is only 21%. By this account, nitrogen should be the one that crosses the alveolar wall, crosses the capillary wall, and ends up in our bloodstream and in all of our tissues. However, that is not the case because nitrogen is not soluble in water under normal conditions. It is oxygen that satisfies both rules. Oxygen has a fairly decent partial pressure, about 21%, and it is also soluble in water, and so it is oxygen that ends up in our tissues. So let's make this clear. Under Henry's law, we now know that in normal conditions, it is oxygen that ends up in our tissues. So oxygen diffuses across the capillary and alveolar walls, and they end up in all of our tissues. Nitrogen, on the other hand, does not diffuse across the alveolar and capillary walls because they're not soluble. It is not soluble in water, and so it ends up being exhaled along with carbon dioxide. The solubility of nitrogen can change profoundly in the ocean depths. Let's see how that happens. At sea level, atmospheric pressure is considered to be 1 atmosphere. At 33 feet below sea level, the atmospheric pressure doubles. At 66 feet, it triples. At 99 feet, the atmospheric pressure is 4 times that of the atmospheric pressure at sea level. At this high pressure, the solubility of nitrogen changes profoundly. Nitrogen, which has a very high partial pressure normally, increases even more at this very high pressure. And so it overrides the solubility factor, and nitrogen can diffuse across the respiratory membrane and reach the body tissues. This happens when a scuba diver reaches the depths of 99 feet. Nitrogen can enter the tissues. So nitrogen now enters all the body tissues, including the brain. When it reaches the brain, it causes a narcotic effect called nitrogen narcosis. This is a pleasurable state which is often referred to as raptures of the deep. Once the scuba diver wants to come up again, they must do so very slowly. This is important because this allows time for the nitrogen to slowly leave the tissues as the pressure keeps decreasing. As the pressure decreases, the solubility of nitrogen also decreases, so it comes out of the body slowly. However, should the diver come up too quickly, then there is not enough time for all the nitrogen to leave the body tissues. Nitrogen now becomes sequestered in the brain and in the joints. This causes a painful condition called the bends or decompression sickness because the nitrogen that is bubbling out of the joints causes great pain and discomfort. Deep sea divers are advised not to fly for 24 hours since their last diving incident. This is because the 24-hour period will allow enough time for all the nitrogen to leave the body via exhalation. If the 24-hour rule is not followed, then there is a higher risk for a diver to experience acute decompression sickness. This is because when the airplane takes off, it gains altitude and loses pressure rapidly. And this can bring on an acute decompression sickness because any nitrogen that's trapped in the body will come out rapidly and cause great pain in the joints and produce other symptoms of decompression sickness.